if I am going to take the number system, one is unsigned number system, another one is signed number system, right? So basically, if you are going to have 3 bits, if you are going to have 3 bits like 2 power 0, 2 power 1 and 2 square, you are going to get these combinations, right? Is it okay? Right? So we are going to get 8 combinations starting from 0 to 7, right? So in unsigned number system, unsigned means there is no signed representation. If there is no signed representation, how many values you can able to store? 7 with help of 000, 1, 2, 3, 4, 5, 6, 7. Is it okay? So 7 I can able to represent as 111. Whereas coming to signed number representation, again it is classified into 3 types, right? According to our explanation. So if you observe, one is signed magnitude representation. Signed magnitude representation. So in signed magnitude representation, if I am going to have 3 bits, one bit should be reserved for what? Sign. One bit should be reserved for sign bit, right? So if I am going to have 3 bits, one bit should be reserved for sign bit, right? So then, with the help of other 2 combinations, how many values you can able to generate? Maximum 3. I mean 4 values you can generate from 0 to 3. So 0 0, 0 1, 1 0, 1 1. Right here, in place of this one, I can able to place either 0 or I can able to place 1. Right? If I am going to place 1, again 0 0, 0 1, 1 0, 1 1. Right? Then what is this value? This value is 0, 1, 2, 3, minus 0, right? So minus 1. So I hope you understood, right? This value is 1, this represents minus. This value is 2, this represents minus. Value is 3, represents minus. Observe now, right? So in signed magnitude representation, we are going to have 2 kind of patterns: 000, 100, equate to same 0. Is there anything like positive 0 and negative 0? No, there is no such thing. That is one drawback. And also the thing is, if you are going to work with any kind of signed magnitude representation, you need separate kind of hardware. Hardware means separate kind of circuit, right? You need to identify what is the MSB bit, what is the LSB bit, all those things you have to identify. You have to make it some kind of other kind of working process, right? So that is the reason they moved to work with the complementary system. Among those, one kind of complementary is one's complement, and another is two's complement, which we studied just now, right? So what is one's complement? Just make it converse of actual value. If it is 000, its converse is 111. Converse is 111, right? So for 111, what is the value you are going to get? In one's complement, if I am going to give the value as 111, means it is 0. Try to observe. 000, its complement is 11, which is equivalent to again 0. Is it okay? Right? If I am going to say that 0 0 1, its complement is what? 110, that is 1. That is 1. So this is what, normal 1 or complement 1? Complement 1, meaning that it should be minus 1, it should be again minus 0 only. Right? There is no meaning for minus 0. That's why I didn't write. Like for your understanding, I am going to make it as minus 0. Right? So 110 represents what? Minus 1. Is it okay? Right? So I have taken the same normal number. I am going to make it complement. Complement means opposite to the value. upward to the value, right? So similarly 0 1 0 1 0 1, this is 2, which means 101 as minus 2. 101 in 1's complement will act as minus 2. 101 will act as minus 2, right? Next 1 double 0 0 double 1 will act as minus 3. See, 1 double 0 value is what? 1 double 0 is actually 4. 1 double 0 is actually 4, right? But it will act as minus 3. Why? Its complement is minus 3 itself. That's it. Its complement is minus 3. Similarly, if you are going to represent like triple 0, its complement is 0 only. And 0 0 1, its complement is 1. And its complement is 2. Is it sufficient? One minute. See, try to, don't get confused. I just divided into two parts only. One is positive part, another one is negative part. So I hope you got up to here. 1 double 0 will act as minus 3. And the remaining part as it is above should be worked as it is. Like it should be 0, 1, 2, 3. 0, 1, 2, 3. Similarly in 2's complement also it will work as it is. 0, 1, 2, 3. 0, 1, 2, 3. And what about the 2's complement representation of this 1 double 0? 1 double 0, 1 double 0, like if you take any number 1 double 0, which is actually what value? 4, 4, right? What is 2's complement? 0 double 1. For this, if you are going to add plus 1, you are going to get 1 0 1 0 1 double 0, 1 double 0, right? What is the meaning of this one? Minus 4, right? You have given the 4 as input. I am going to take its complement. Take its complement. So complement of a number is negative number, minus 4. Similarly, take out 1 0 1, 0 1 0. For this plus 1, 0 double 1. 1 0 1 is what value? 5, 5. What about its complement? 0 double 1. Is there a relation? Are you going to find out? No, no, that is not the thing, right? Here you have to find out. See, this is for your understanding. I have taken. Don't always take these values, right? So next part, see, if I am going to represent any data with 3 bits, how many values are you going to get? I have a question for you. If I am going to have a number, 12 in base 10. How many minimum bits are required in order to represent the number 12? These 3 bits are sufficient? Yes, sir. No. 4 bits are required in order to represent the number 12. Number 12. Similarly, if I am going to have a 2's complement number, in order to represent the number 5, is it possible to represent the number 5 in 3-bit system? Is it possible? It is not possible. So what you have to do now, see, try to observe. Here 0, 1, 2, 3 are possible values. Positive values. What about the negative values? If you take the number 3, value is what? 0, 1, 1. 0, 1, 1. For this 1's complement is 1 double 0. For this 2's complement is 1 0 1. If I am going to have 1 0 1, which means what? Minus 3. I have taken the number 3. I just written the binary system. I find out the 2's complement. I got the 101, which is minus 3. Meaning that wherever 101 is there, in that particular location, I am going to write it as minus 3. Minus 3. Similarly, if I are going to find out, it should be minus 2. It should be minus 2. Observe, if you want, try to take out the value of 1. Value of 1 is 001. Try to take out its complement 110. Add plus 1, so 2's complement we are going to get. That should be 111. Wherever 111 is there, that is complement of 1 in 2's system. Okay, now fine. This way you can able to do. See here the point is, so these are the points which are important for the gate. So here, if you would like to represent any kind of a number, any kind of a positive number, that is unsigned number representation. If I am going to have 3-bit system, what is the maximum values I can able to get? Can I generalize the formula, which you already know? 2 power n minus 1. Is it okay? Right? What is n here? 3. 2 cube is 8 minus 1 is 7. So total maximum number is 7 or not? Maximum number is 7. So what is the range of values that you can able to generate if you are going to have a 3-bit system in unsigned representation? 0 to 7. That is 0 to 2 power n minus 1. What about signed magnitude representation? See, observe here, the values are from, if you observe here, one is 0 to plus 3, another one is minus 0 to minus 3. See, according to logic, there is no minus 0, but the way we got here, I have just written here, right? Is there any use of representing 0 and 0 in both ways? No, we can able to have only one way. So, what is the range? How can we generalize this one? See, if you observe this thing, the entire number of numbers generated. What is the number of numbers generated? So if I am going to have 3-bit system, total numbers are generated are 2 power n. 2 power n, that is 8, right? So that is divided into two parts. First half of the part is for positive and second part is for the negative numbers, right? So how we are going to divide an n-bit system? 2 power n by 2. 2 power n by 2. So each part will contain 2 power n minus 1. 2 power n minus 1. If it is this sign magnitude representation, what is this representation? Positive values are ranged from 0 to 2 power n minus 1 minus 1. What about the negative values range? 0 to minus 2 power n minus 1 minus 1. Is it okay? If you want, you can just substitute the number 3. 2 square minus 1 minus 4. Sorry. This should be minus. Right? 2 square minus 1 is minus 3. Okay. Similarly, what about this representation in 1's complement? What about in 1's complement? Are you going to get the same or not? Because the range of numbers are from 0 to 3, 0 to minus 3. So the range is from, again, so simply I can write like minus of 2 power n minus 1 minus 1 to plus of 2 power n minus 1 minus 1. Is it okay? What about the 2's complement? See, this is the advantage. So in 1's complement or in sign magnitude representation, we can able to define only 7 unequal elements. Whereas coming to 2's complement, are you going to get 8 unequal elements? Because the minus 4 is there. So what is the range I can able to define? Minus of 2 power n minus 1 to plus of 2 power n minus 1 minus. Okay, na? I think this generalization is okay for you, right? So now, so with respect to this concept, so if I am going to have a number like minus 3, minus 3 in decimal number, minus 3 in decimal number, which is in 2's complement representation, which requires to represent in 2's complement. How many number of minimum bits are required? See, question is, I want to represent minus 3, which is in decimal number system, want to represent in 2's complement representation. How many bits are required? Observe, minus 3. If you want to represent 2's complement, what is the value? 101. How many bits are required minimum? 3. That is the answer. So the answer is 3 bits are minimum required in order to represent the minus 3. So the same thing, if I am having a 15 with base 10, I want to represent the same number in 2's complement. How many number of minimum bits are required now? 5. How? Is it okay? Is 5 bits are enough? Right? So if you want, you can just, so 15 means I can write as like this, 4 ones, right? For this, try to find out the complement, 4 zeros. For this, you can able to add plus 1, then you are going to get 0001, 0001, right? So this is 2's complement of 15, 2's complement of 15, right? 4 bits are required, 4 bits are required. So try to solve this. I mean, try to solve means you have to make it generalize also. How can you do that? So is 15 is 4 ones only, right? What is the ones complement of 4 ones? 4 zeros. Then I am going to add plus 1. Then it is 2's complement. So 0001. 0001. See, this represents what? 1 or minus 15. Or minus 15. See, this is 15. 15. 15 in 2's complement is equivalent. If I am going to find out, this will be equivalent to minus 15. But the question is, in order to represent the number 15 in 2's complement, how many bits are required? See, I mean, if I am going to have 4 bit space, 4 bit space, I can able to represent minus 15. I can able to represent minus 15. If it is going to support minus 15, can it support plus 15? If it supports plus 15, if it supports minus 4, can it supports plus 4? According to this particular like generalogy, it is not supported, because in order to represent more than negative number positive side, you have to require one more bit. So 4 bits are not sufficient. So you can go with the 5 bits. Go with 5 bits, right? So basically in the examination, this will be not like a simple numbers. So it will have a maximum numbers. So what you can do now? So in 2's complement, what is the maximum number you can able to generate? Generally, what is the range of numbers you can able to generate? Minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. Meaning that if I are going to take a scale of like this, my 0 will be like this, 2 power n minus 1 minus 1 minus 2 power n minus 1. What value they asked? They asked 15 here, which is somewhere, right? So in order to represent this 15, I have to find out the n value. So this n value should be compulsory greater than or equal to 15. See, observe. So what is the maximum number I can able to generate? 2 power n minus 1 minus 1, which should be greater than or equal to the decimal number 15. Now try to solve. 2 power n minus 1 greater than or equal to 16. So which is equivalent to 2 power 4 n minus 1 greater than or equal to 4, n greater than or equal to 5, n greater than or equal to 5, right? So earlier I had said like a kind of a general overview example. Now with the help of some kind of logic, I made it as conclusion. So here compulsory n value should be greater than or equal to 5 only. Without the greater than or equal to 5 bits, it is not possible to represent the 50, right? Similarly, what about minus 15? What about minus 15? Is 4 bits are sufficient? Yes, try to check that. Try to check it, right? So minus 15 is available here. So minus 15 is greater than or equal to minus of 2 power n minus 1, right? So 2 power n minus 1 should be greater than or equal to 15. Is it okay? Right? Now try to check. 2 power 4. 2 power 4 is 16, right? 2 power 4 is 16, right? So don't go with approximate values. Try to find out the exact values so that you will get clear idea. So how we are going to solve this one? Ma? If you take n value 4, if you take n value 4, is this equation is going to be satisfied? No. Take out the n value 5. Take out the n value 5. So if you take out the n value 5, that means 2 power 5 minus 1, that is 2 power 4, which is greater than or equal to 15. Which is greater than or equal to 15. So in order to represent the minus 15, in 2's complement reference system, I require compulsory 5 bits. I require compulsory 5 bits. But according to this logic of representing a 15, see, this is completely different and this is different. This is minus 15 and this is plus 15. See, you should not compare these values. Okay, so this is correct. So decimal number of, so number of bits are required to represent the minus 15 is 5. Okay. So similarly, like for example, here try to think, if I am going to take these values, I hope it is visible. So if you would like to get the value minus 3, if you would like to get the value minus 3, how can you get this value? Can I have any generalization? Right? I will take the new slide only. If you take here, if it is unsigned number representation, if you want to have the number 7, it should be 2 power 0, 2 power 1, 2 square, 1 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0, which is 7, right? So this is one kind of unsigned representation formula. What about the signed representation, signed magnitude representation? You have to perform addition of all the numbers 2 power 0, 2 power 1 and so on and so on. So you may get positive sign or you may get negative sign. For the last bit, so last bit represents what? Sign magnitude, right? So last bit represents sign magnitude. So that should be multiplied with powers of minus 1. Minus 1 power MSB bit. Right, observe. If I am going to have a number like 110, number 110, what is the signed magnitude of this actual decimal number? This is what? So you have to multiply addition on all these things. So up to here it is 2. 2 into minus 1 power, what is MSB? 1. Minus 1 power 1 is minus 1. Minus 1 into 2 is minus 2. which is equivalent to 110 or not? Minus 2 is 110. 110. So like this, if you are going to find out any kind of rule for one's complement, you cannot able to get anything. You cannot able to get any kind of thing. Okay. So if you want, you can able to try to find, but there is no generalization you are going to get. Whereas coming to 2's complement, it will be like 2 power 0, 2 power 1, 2 square, and so on, and so on. The most significant bit is minus 2 power n. Minus 2 power n. Then you are going to get that. For example, try to take out this value only. Triple one. Triple one. What is the meaning of this one? 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into minus 2 power n means what? 2 square minus 2 square, normal n value only, right? So then what is going to happen? Minus 4 plus 3, minus 4 plus 3, which is equal to minus 1. Is triple one equal to minus 1 or not? Is triple one equal to minus 1 or not? So check out anything. Take out 100. Take out 100. 100 means 0 into 2 power 0, 0 into 2 power 1 plus 1 into 2 power, sorry, minus 2 power 2. So you are going to get minus 4. Minus 4. Right, guys, try to observe. I am trying to modify a small thing. 1100. What is the value? Minus 4 only. Why? If you are going to solve again, you are going to get minus 4 only. Why? It is consecutively multiples of 2 only. This is what? Minus 8 plus 4 plus 0 plus 0. You are going to get plus 0. So meaning that, so for example, triple one I am going to write it as, what is the value? This value. What is the value of this in 2's complement? Minus 1. Why? Even you are trying to add all these things, the last bit is sum of all the remaining. Right? So I hope you understood. Is it okay? Yes. So sometimes the gate question will be related to this one. Okay. So if you observe here the logic, I am able to represent unsigned numbers in some format like powers of 2 powers, and signed magnitude representation I am going to represent in some kind of formula, and 2's complement I am going to represent some kind of formula. If I are going to represent in some kind of formula, those I can call it as weighted codes. Weighted codes. What is the meaning of weighted codes? Each and every location have a particular value, and if I am going to perform some kind of expression, I am going to yield the same result. Each and every location having some weight. Right? Here if you observe, it is powers of 2. 2 power 0 with index position, 2 power 1 with 2 power with index position, and so on. Here you are going to have powers of 2, and the last position having minus power some MSB bit. Similarly, if you are going to have here all having powers of 2 and the last bit having minus 2 power index position. So everything having some weight. So that's why we call it as weighted codes, and we can alternatively call it as weighted codes. Right? And what about the ones complement? Will comes under unweighted codes. Unweighted codes, meaning that if you are going to represent some weights, you are not able to generalize the data. You are not going to generalize any expression for it. Then I can call it as unweighted codes. Okay, na? For example, guys, so I am going to have, so try to write the question. I am going to have a 5-digit number. I am going to have a 5-digit number, or I can call it as a 5-bit number in 2's complement. 5-digit number in 2's complement. What is that maximum value? I mean, what is the maximum number that can be generated with help of 5 digits in 2's complement? What we can do, ma? 2 power minus 1. This is the maximum positive number I can able to generate, right? So what they are saying it is a 5-bit number. 5-bit number. Place in place of n with a value 5. So place 5, 2 power 4 minus 1. This is 50. So meaning that with the help of a 5 bits in 2's complement, I can able to represent maximum of 15 decimal number. Right? For example, I am going to have minus 16 base 10. Minus 16 base 10 in 2's complement representation. In 2's complement representation, can we able to represent with 4 bits? Minus 16. Is it possible to fit minus 16 base 10 in 2's complement representation of 4-bit representation? Right? So the simple thing is, it is not possible. So it is not possible. So basically, if you observe the formula, minus 2 power n minus 1 to plus 2 power n minus 1 minus 1, right? If you are going to substitute the value of 4, you are going to get minus 2 cube 2 plus 2 cube minus 1, meaning that minus 8 to plus 7 I can able to place, but they have given as minus 16, so it couldn't possible to fit this value. Okay, fine. So with the help of this concept, I can able to extend, like, if I am going to have a number, like for example, uh, if it is something like 0 double 1 0, 0 double 1 0, right? So assuming that this is normal positive number, plus 6, can I extend it to something like 8-bit system? See, my point here is, it is 4-bit system, so I can able to write 0 double 1 0 for positive 6. Can I extend the same with 8-bit system? Yes or no? I can extend. What you can do simply, you can able to simply add remaining 4 zeros. There is no problem. What about if it is minus 6? See, 1 1 1 0. If it is, so it is minus 6, right? It is minus 6. What about in 8-bit system? What we can do? So sign bit should be separated with the remaining data 1 1 0, and you have to fill up with the 5 places. I think 5 places. This sign bit should be taken with the last one, and all the remaining places should be occupied with 0. So this what I can call it as sign bit extension. Sign bit extension. So how we are going to extend the uh, places of the storing data, right? If it is 4 bit, okay. If it is 16 bit, you have to extend it. How we are going to extend? Okay, the same number, for example, if it is in ones complement, if it is ones complement, right? So plus 6 is actually what? 0 110, right? If it is in ones complement, what is its value? 1001, 1001, right? So which is in which kind of platform? 4-bit system. What about, I would, if I would like to extend it in the 8-bit system, what about the same plus 6 in 8-bit system? What we can do here? Simple thing, you can just simply write 8-bit system for the actual data of plus 6. 8-bit system, if you are going to write 4 zeros, 0110. For this, if try to write the complement, what will happen? 111 1001. So this is 8 bit. Nothing. There is no problem. What about if it is in 2's complement? I think this is 1's complement. What about if it is 2's complement? Right? So basically you are going to have plus 6, which is from 0110, and 1001 is 1's complement, and if I am going to add plus 1, you are going to get 2's complement. 1010, 1010 is 2's complement, is 2's complement. If the same thing of 2's complement number in any kind of sign bit extensions like 8-bit space, then what is going to happen? Can you write the same procedure as earlier one? See, if you write earlier, there is a mistake. That should not happen. After the result, how many number of bits required? That many number of bits you can able to add, and you can able to simply place all ones. Why all ones? What is the formula for 2's complement number? Minus 2 power n, minus 2 power n, 2 power n minus 1, 2 power n minus 2, and so on, right? Even you are going to write any number of ones. Is there any change in this value? There is no change in this value. It is always going to be minus 6 only. If you want, you can able to calculate, right? So try to perform. This is what? Minus 2 power minus 2 cube plus 2 square plus 2 power 1. Minus 2 cube is what? Minus 8 plus 2, which is equivalent to minus 6. If you want, you can able to include all these numbers. Again, you are going to get only minus 6 only. So when you are trying to perform in 2's complement number, just simply extend the remaining number of bits with the 1.